When Henry Ford first built the Model T, he thought that biofuels, fuels made from plants, were the fuel of the future. So it is somewhat ironic that experts around the globe today are in a mad dash to convert things like tree pulp and corn into ethanol to power our cars. Dr. Art Ragauskas is one such expert from Georgia Tech, and he is here with an update on just how it's going. Thank you. You're extremely busy, but you are on the cutting edge, so it's a thrill to have you. Tell me this, why trees?
Well, Carol, I think it's a really exciting time to be here. And trees basically for Georgia are, if you want to make biomass, and convert it to biofuels, you need a natural resource. And we all know if we go down 85 or 75, the state is blessed with trees. It's one of our most popular, highest volume materials that we could use to convert to biofuels.
Well, we have a $22 billion forest industry here, and with paper plants moving out and that some of the business going with it, the dollars going with it, it's nice to have something to do with what's left behind, especially some of the rubbish, the trees, the branches, etc. You had commented that regionally it is smart for people to look at what is in their backyard because you have to ship the biomass in order to make it. So be smart. If corn is what's growing in your backyard,
then you can use corn. And indeed that's what the Midwest is blessed with, and we know Georgia is primarily blessed with trees. There are areas that we have a strong agricultural base that we can use switchgrass in for lands that are not as productive. And you always see the burgeoning biodiesel industry that uses animal renderings and other plant oils for biodiesel.
Okay, give me a quick, really brief, dumbed-down version of what it is that you do when you take that pulp or that tree branch and convert it.
Well, what we're interested in doing is trying to make it, as many people are on campus and almost worldwide, is to make this a more efficient process. You can actually do it right now. You can convert cellulosic materials to ethanol, but it's not that efficient, and you can translate the word efficient into more costly than we'd like.
Okay.
Basically, you have to take a biomass, let's say trees in Georgia. You collect them, you grind them a little bit, and then you have to do a pre-treatment. You have to do what's called a pre-treatment because the biomass is recalcitrant to deconstruction enzymes. Okay. If you can reduce the recalcitrants, you can improve the efficiency of the pre-treatment or remove it. After you
Which again makes it more cost efficient.
Makes it more cost efficient.
Okay.
After you deconstruct it with a set of enzymes, you ferment it and you distill it and you have ethanol.
Basically you heat it and then condense it?
You heat it, you ferment it, just like old-fashioned moonshine, so
All right, what are the biggest hurdles right now? The breakdown, these enzymes?
The biggest hurdles is this pre-treatment. Mother Nature makes a tree to be out there for 30 to 40 or 50 years.
Darn her!
And what we want to do is take that tree and break it down to its simplest of sugars. And then once we have those sugars, then we can ferment it to ethanol. But
so one of your big hurdles right now is just simply the breakdown.
Is the breakdown of the tree to simple sugars.
All right. Who is at the table with you right now? Because you're part of a couple different alliances and you're working with companies or universities around the globe.
As we mentioned before, as when you and I go buy gasoline, what we really buy is a system that delivers that gasoline to the pump. And what in the conversion of biomass to biofuels, you also have a system that you have to have, from collection to growth to conversion to ethanol. And each of those has a serious research challenge to it. We believe some of the highest ones are the recalcitrance of biomass. And in there, I'm team leader for an effort on the Georgia Tech campus, and that's coordinated with Imperial College in London and Oak Ridge National Labs in Tennessee. And we also, just recently, I was a part of a larger team for the Biological Energy Science Center, which was funded out of DOE, that has partners at UGA, has Oak Ridge led it, there's National Renewable Energy Labs, there's Dartmouth, and if I try to name them all.
You are in the thick of things.
Absolutely.
And on the edge, and there's a lot of collaboration going on, which isn't always the case in research, but it is here.
Yeah.
Okay, so as we move through this process, I think the real upshot, people are wondering, how long is it going to be before that pulp is at the pump? Can you tell me?
Well, I would prefer to use the word where the wood is at the pump.
Okay.
But, I mean, there's a whole set of exciting things that have just kind of accelerated in the last 2 years. One, the Department of Energy is now going to fund 6 large-scale pilot plant demonstration plants for the conversion of cellulosic ethanol. Okay.
And one is here in Georgia?
One's here in Georgia. 3 are thermal and 3 are biochemical. And they are co-funded, so in essence there's a large private industry component in there. And those are targeted for completion of construction, some are like end of 2008 to 2011. So they will be contributing to that solution. There's been another solicitation that recently came out called the 10% solution, looking for a more industrial development. Okay. And at the same time, those are taking probably cutting-edge commercial technologies. What you have is a set of researchers at academic and national labs looking at some of the really big fundamental challenges, which if they are solved, will dramatically improve the efficiency and reduce cost.
Okay. So am I hearing 2, 3, 4, 5 years?
I think in 2 to 3 years, you
Okay.
will certainly have those pilot plant facilities providing the nation biofuels, either whether it's bioethanol or others. You can go outside of Oglethorpe right now, and I know you can buy E85 there. I've actually filled up myself.
All right. Best case scenario, how much am I going to pay per gallon?
Whoa. Best case scenario, if what we do to address some of the fundamental issues that still make it expensive for cellulosic ethanol, then you're looking for something that at cost is $1 to $1.50 a gallon.
All right. You and I had talked on the phone prior to this interview, the difference in the cost of building plants for, say, the conversion of trees versus corn. And originally I had heard, because everyone's on the corn bandwagon, originally I had heard it was more expensive to build the tree plant.
That's correct.
Than the corn, but the corn actually in the end was going to be more expensive. Is that your assessment?
That's briefly, yes, it is. And part of that is a large amount of the expense comes from this pre-treatment. A good friend of mine who I work with, Dr. Charlie Wyman out in the West Coast, says the second most expensive part in the conversion of cellulose to ethanol is the pre-treatment. And the only thing more expensive than that is not doing the pre-treatment.
Okay.
So if we could, and we were actively involved with a set of researchers, both in the state and nationwide, at looking at changing the genetics of the plant to reduce the recalcitrance of the plant itself.
Are you talking about making designer trees?
Designer plants almost.
Okay.
And changing the nature of that biomaterial so that it is less recalcitrant. Again, going back to before, Mother Nature doesn't want a tree to fall apart in 10 years. It wants it to hang there for, as we know, if you walk through the forest, it stays there for a long time. But we can reduce the recalcitrance, and the amount of pre-treatment we have to do could be almost taken to zero, which there are theoretical reasons we may not want that, but dramatically reduce, so perhaps all we have to do is treat plant material with hot water, and then can use the enzymes for deconstruction, and then from deconstruction to fermentation.
All right. Compare that to corn or sugar cane or soybeans, I've also heard. Is the breakdown on those a little easier?
Oh, it's much easier.
Okay.
Much easier. And much more, not only is it much easier, it's really well established now.
We've got that. Now, you had also started to tell me that we're not just using the kernel.
Right.
Potentially, we are using everything. The stalk, the cob.
That's the vision. I mean, that's the vision. If we can, you can do this right now. And there are I mean, this is the 6 plants that are set up. We'll use some of the best technologies we have right now for conversion of cellulosic material to ethanol. But if you look at some of the challenges which makes the process more expensive than we'd like, you can address those with science and engineering.
All right. When you compare, again, trees to corn to soybeans to sugarcane, you say the other 3 tend to be a little easier. We know that Brazil, for instance, is completely self-sufficient using sugarcane.
Right.
Sugarcane doesn't grow particularly well in Georgia, so we're not using it here. Does it make any sense for, say, other countries to, like you said, Africa, also opportunities for growth there, and ultimately ship it up to Europe?
A variety of countries are all trying to do self-assessments of their bioresource inventory and what works for them. Clearly, no nation wants to displace their food production capabilities for biofuels. You don't want to get in the food or fuel argument. But there are
in your opinion, we can do both. We can feed and fuel.
Absolutely. To give you a really funny example, in the mid-1990s, I used to get phone calls of, could you do anything with rice straw? Can you make paper out of it? And you can make paper, but it doesn't make a great paper. And the reason for that was you couldn't burn the excess rice straw that was on the land because it was an environmental issue. Well, this is a beautiful resource, the conversion of bioethanol. So the question is, what waste agricultural materials that we have right now can we convert efficiently to biofuels?
Why haven't we done something sooner? We all remember the energy crisis in the 70s. Why have we not moved faster?
Well, I think we have in the past we've had substantial efforts in this area. They've gone up and we've gone down, as we well know, but there was always some passionate people that were involved in this field. And truthfully, I mean, we all know, we all know the answer. The price of oil was blessedly cheap. But as the rest of the world has become economically growing, demands more of the natural resources in terms of petroleum, prices have gone up also. And then, the other thing is, one of the things I think is so exciting is we're at a really marvelous time. We as a nation have invested enormously in genomics. We've invested enormously in nanotechnology, process science and engineering and computational capabilities. Some of the challenges that have to be addressed, I think historically, couldn't have been addressed. We just weren't ready to do it. But we really, as I tell my students, we stand on the shoulders of giants and giant accomplishments that simplify some of the things that historically would have been very difficult to do.
Okay. So the federal government is starting to come around, obviously. Right. Still needs to come around some more, but come here. Automakers, you would say they have stepped up to the plate.
Correct.
And that what you're currently going to provide, or what you attempt to provide, will go right into a car that's being made today.
Absolutely. I mean, let's say if you go back a decade ago, there's a Department of Energy website in which it highlights the cars that can take E25 or E85. And about a decade ago, it was about a handful. I mean, it was easy to count the ones. Now it's easier to count the ones that cannot take E85.
Which is amazingly exciting.
Exactly.
Tell me this. When you look down the road, the lifespan of this particular effort, is it renewable? Is it forever?
I think that after the science and the engineering, that will be the real big challenge, and it'll be a social public challenge in the sense that we have to develop policies that will allow us to have productive lands, because if the land becomes unproductive, all of this falls apart. But there's already been research demonstrated on field trials that you can take a certain amount of biomass off the land and still have as productive or even incremental improvements in the productivity of the lands. But we will have to have policies to make sure that no one takes every last piece of biomass off to the detriment of the long-term productivity of the land. Now, what I would argue is if you look at the forest products industry, which has a history of taking wood off of lands and knowing that they're going to come back in 20, 30 years for another crop, clearly industry can do this, and they can acknowledge it. But I think you do need policies, you need guidelines, you need education to let people know how much of that can be done.
When you look at the political will that's kind of blowing, and everybody kind of immediately jumping and not grabbing at straws, but it needs to be done, as you commented, very methodically.
Right.
Do you have the, I don't know, the gut sense that it can be done and will be done correctly?
Yeah,
not just in this country, but globally.
Boy, globally is a more difficult. You have different societies with different value structures. I think certainly, in this country and in other parts of the world where you have a good public policy, organizational stance, and you also have educated people and you have the educational resources to get that out to the people who actually do it, I think that's really exciting.
It is. It's overwhelming.
Yeah.
I mean, the task at hand is overwhelming.
Yeah. Well, my history is in forest products. And, I was always told that industry is a volume industry. It makes a lot of stuff. But then when you do the volume of fuels, my gosh, it's the biggest thing we as a society move around in the world, really.
All right. Well, your challenge is huge to go, literally from the lab to the pump. And we all wish you luck, and we hope it goes well. And we hope you can do it at a really great price. Thanks very much, Art. I appreciate your time.
Appreciate your time, too.
That is our broadcast. Thanks for joining us, and thanks for watching Georgia Public Broadcasting.
This has been a production of Georgia Public Broadcasting.